Hi everyone! Today we're going to be talking about how some big explosions that happened a long time back taught us a lot about how we can release energy and use it for ourselves. Ooh, yeah! Imagine you have a giant Lego tower made out of thousands of small pieces of Lego. You need a lot of effort to put them together or take them apart, and sometimes you even need Mama or Papa's help, right? So, if you take these Legos apart very quickly or can put them together really quickly, you release a lot of energy. And some special bombs work by taking apart these Lego pieces called atoms. As you can see here, and these atoms are tiny building blocks that make up the world around us. So, there are two kinds of special bombs. One works by putting together these building blocks called fusion. And this is how the sun makes their energy. The second one works by taking apart these smaller pieces called fission bombs. And this is how radioactive sludge comes about. Both of these bombs release a lot of energy when they explode. This is why we have to be careful not to use these bombs at all, because it keeps people safe and helps to reduce damage to the world around us. So, if you have a green landscape and if you drop a bomb on it, boom! And this turns the entire place into a deserted area. This is because it kills everything and anything in its path. This is why we should never use these bombs at all. So, that's the end of the lesson. Hopefully you learned more about how these bombs release energy and why we need to not use these bombs to keep the world around us safe. Thank you so much, and I hope you come by for the next lesson. Bye-bye! Morning, Junior High. Today we'll be talking about how two famous bombs that were used during World War II, the boy and Fat Man, worked and how they led to the development of thermonuclear bombs. As depicted above, nuclear fission is splitting of a large thermonucleus into smaller particles, releasing vast amounts of energy. On the other hand, fusion is a combination of light or smaller thermonuclei to form a heavier nucleus, also releasing a large amount of energy in the process. However, to release the amount of energy similar to that of a nuclear bomb, you set off a chain reaction of these fission or fusion processes. Scientists have specific terms for masses that can sustain a chain reaction, called a supercritical mass, and a term for masses that cannot sustain a chain reaction, called subcritical masses. Both Little Boy and Fat Man were fission bombs that split large thermonuclei into smaller nuclei to release energy. The two main differences between them were the methods they used to trigger the chain reaction and the initial nuclei used. Little Boy used subcritical masses of uranium that were brought together by a gun-like mechanism. Fat Man, on the other hand, used a implosion method to trigger the chain reaction between the plutonium nuclei. Implosion is when something collapses violently inwards, leading to subcritical plutonium masses joining together to form a supercritical mass. These two bombs led to 66,000 immediate deaths and 69,000 injuries on immediate impact, causing massive destruction and loss to the Japanese people. But that was not enough for the scientists. They went on to invent even more powerful bombs, or hydrogen bombs on the other hand, used both nuclear fission and fusion to achieve explosions magnitude stronger than Little Boy or Fat Man, 1,000 times stronger than them. These were developed during World War II, showcasing how much stronger bombs have gotten over the years. The question then arises, how are these bombs not being used around the globe in wars, especially if they warrant an immediate victory? There are treaties in place to ensure that these bombs do not get used at all, ensuring global peace and security. Hopefully, from today's lesson, you've learned more about nuclear fission and fusion and how these methods have been used to create bombs of great power in the past. By understanding these concepts, I hope you have a better understanding of why these bombs should not be used to ensure global security. Thank you. Good morning, Senior High. In today's lecture, we'll be learning more about how Little Boy, Fat Man, and thermonuclear bombs in terms of the physics concept that turn these bombs into reality and how the mechanisms behind these bombs work. So, here's a quick content outline. We'll be starting off with Little Boy, then moving on to Fat Man, then thermonuclear bombs, and lastly, how to maintain peace. So let's have a quick recap of nuclear fission. Nuclear fission is when we split a larger atom into two or smaller ones, and fusion is when we join two or more lighter atoms into a larger one. So, a subcritical mass is not enough to sustain a chain reaction, while a critical mass is more than enough mass to sustain a nuclear chain reaction. This is how a supercritical mass of uranium leads to a chain reaction of fission reactions here. So now that we understand the basics of nuclear fission and nuclear fusion, let's move on to Little Boy, which used a gun type designed to project a 35 kilogram subcritical mass of uranium into as a projectile to another 25.5 kilograms of uranium, such that it forms a supercritical mass that could sustain a nuclear chain reaction. So here is the equation of the fission over here. The uranium-235 nucleus absorbs a neutron, splits into barium-141, krypton-92, and 3 neutrons, releasing a significant amount of energy, or Q. To calculate the energy Q, you need to find the difference between the reactants and the products. Then use Einstein's equation E equals to mc squared, where E is the energy released, m is the mass effect, and c is the speed of light. Fat Man, on the other hand, was a plutonium bomb that used a different design called the implosion method. Conventional explosives were used to surround the plutonium core and were then detonated simultaneously to compress the plutonium into a supercritical state, triggering a chain reactions. So the equation of the reaction is as such, where a plutonium-239 nucleus absorbs a nucleus, and then splits in barium-141, krypton-92, and 3 neutrons, releasing a large amount of energy in the process. And once again, you can use Einstein's equation, the method, to calculate the energy released. So far, we've only explored fission bombs. The question then arises, what if we combine fission and fusion? But 66,000 died during World War II, and 69,000 were injured during World War II. So should we move on? Absolutely. So this led to the invention of thermonuclear bombs, which utilize both fission and fusion to release a larger amount of energy. Fusion involves combining hydrogen isotopes, such as deuterium and tritium, which can be represented below, where deuterium and tritium fuse to form helium and a neutron, while releasing massive amounts of energy. So this is just a fission. How does it involve both fusion and fission, you might ask? So, a hydrogen bomb has two stages, which involve a primary stage of a fission bomb and a secondary stage of a fusion bomb. The primary stage is a fission bomb similar to Fat Man, using conventional explosives to compress a core of plutonium or uranium, initiating a fission reaction. The second stage occurs when energy from the fission bomb is used to compress and heat a secondary stage containing fusion fuel, usually a mixture of deuterium and tritium. The extreme temperatures and pressures trigger the fusion reaction. The fusion reaction not only releases energy, but also produces fast neutrons that can induce further fission in the bomb's casing, leading to even more energy released. This led to the invention of bombs like the Tsar Bomba, the most powerful hydrogen bomb ever detonated, which led to a yield of 50 megatons. For scale, that is thousands of times more powerful than the bombs dropped in Hiroshima and Nagasaki. It's needless to say that the development of these powerful bombs like the Tsar Bomba has had an irrevocable impact on international relations and global security. As such, we have nuclear weapon-free areas to help protect us from the usage of these nuclear bombs. And we also have treaties to maintain peace, such as the Doctrine of Mutually Assured Destruction, as well as the Nuclear Non-Proliferation Treaty. So, in conclusion, we learned about nuclear fission and fusion, subcritical and supercritical masses, the gun design of Little Boy, the implosion design of Fat Man, and the dual mechanism of hydrogen bombs, as well as the treaties. Thank you very much for listening, and I hope to see you in the next lesson.